Hello everyone. It's a new day and it's a new beginning. And before even beginning this video, I just want a feedback on my new thumbnail regarding this series that we are covering regarding the web performance. So this is the thumbnail that I have created. It look like this. How is this looking? How can I improve it? If you have any suggestions, you can please pin me in comments. I know last video in this series have not got any views. So might be there will be no any comments regarding that, but never mind. This video is never meant to be mass viewed, but as a improvement channel. So we will continue our reading our Cloudflare articles, specifically the web performance one. So I will visit the Cloudflare. Let's switch the screen so you guys can also see. We initiated a search toward Cloudflare, and as you can see the first element, and after that a few elements have started loading, and this is the time it taken to become the what was that, the first paint, first contentful paint. It's like something as per the previous article have learned about performance. Now in the performance section we have to navigate towards speed matters. No, we have studied performance benefit up to core wave vitals. And now, time for my favorite topic, load balancing. So, we will start discussing first what is load balancing. And I think for this scenario, I have to turn off dark mode so you guys can see these kind of PNG formats. If you look closely, you can see that there's an arrow. So don't worry, I won't be turning off the dark mode, and I will try to explain it using my own beautiful drawing. Don't worry. Let me minimize this. So the less distraction we have on screen, the more focus we can become. So starting from this, load balancing is the practice of distributing computational workload between two or more computers. Okay. On the internet, load balancing is often employed to divide network traffics among several servers, reduce the strain on each server, and makes the server more efficient, speeding up performance and reducing latency. Load balancing is essential for most internet application to function properly. So what this diagram is saying, 1 second, let my pen load. Yes. So suppose these are the five devices, 1, 2, 3, 4 and 5 devices. And this is the server for the device. Suppose the four devices are actually targeting the same server. All the four devices will receive the traffic slow, and this server will become overburdened, overloaded. Okay. And if there is a load balancing present in the between scenario, what will happen? We have something as a proxy. A proxy is a device that is in between the connection. It does not process something of its own, but it only passes the traffic between all the servers that are available for serving the same content. So in this scenario, what we meant is the same content is stored over here, 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 and here. So same content are over all over the place. But uh, there is no one to decide that the content asked from this second laptop or the third laptop is served by from which server. So normally in typical cases, the content will be served the first server that the request came to. Hence, the first server serves the first request, and after all the requests, all the subsequent requests will be served by the first server. And after a while, server will not able to serve that, and hence become overburdened. Okay. And load balancing, we have a physical device, or load balancing can be virtual as well. So load balancing is a physical device in this scenario which sits between the request maker and request server. So here we have clients and here we have server, and there's a device which automatically divides the load or request on the servers available. And it can be done on the basis of geography, on the basis of load, on the basis of latency, and all the things are determined by the algorithm that is running on the load balancing. Okay, so here is a great comparison regarding this, that imagine a checkout line at grocery store with 8 checkout lines. If only one of which is open, all customer must get into same line, and therefore it takes longer time for customer to finish their grocery. And instead of now imagine that a store in that opens all 8 checkout lines. In this case, the wait time for customer is about 8 times shorter. The wait time will become 1 by 8th for each customer. And load balancing essentially accomplishes the same thing by dividing user requests among multiple servers. User wait time is vastly cut down. This results in a better user experience, and the grocery customer in example would probably look for a most efficient grocery, or which lead to what is a higher bounce rate. So for example, this is a server for a website called Flipkart. Okay, and this is a server for Amazon. Okay, suppose Flipkart, for a single scenario, it does not uses load balancing, so it has 3 servers employed, and we have 6 users. Okay, all 6 requests go into a single server, and the server becomes unresponsive. So what will the users will actually do? So if Flipkart becomes unresponsive for something, user will switch to Amazon, or vice versa. They can do same if Amazon does not employ the same tactics. So this is the scenario that if a website is not performant enough, it automatically leads to what? Automatically leads to user bouncing. Next, how does the load balancing actually work? Load balancing is handled by a tool or application which is called load balancer. A load balancer can either hardware based or software based. The hardware based load balancer requires installation of a dedicated load balancing device, and a software based load balancer can run on a server, virtual machine, or in cloud. So cloud is simply the someone else computer, which is rented, often in the case it is rented computer. So content delivery network often include load balancing features. So when a request arrives from an user, the load balancer assigns the request to a given server, and this process repeats for each request. Load balancer determine which server should handle each request based on the number of different algorithms. And these algorithms fall into 2 main categories. First is static and second is dynamic. And obviously we know that each have their own pros and cons. So a static load balancing algorithm distribute workload without taking into account the current state of the system. A static load balancer will not be aware of which servers are performing slowly, which servers are not being used. Instead, it assigns the workload based on a predetermined plan. So it is quite easy to understand because everything is predetermined here, which means that we have server S1, we have again a server S2, and we have a load balancer LB, which stands for LB. Suppose 6 requests from a user are coming to this load balancer. So we have a predetermined plan that the first request will be sent to this device, second will be this on this device, third will be on this, fourth will be on this, fifth will be on this, and sixth will be on this. So this is how our predetermined is assigned on this load balancer. So static load balancing is quick, it's easy to set up, but has inefficiencies of its own because servers comes in various variety. Suppose this particular server S1 only has a capacity of handling 2 requests, while this server S2 has a capacity of handling 4 requests. It depends on the model of server, bandwidth of server, different types of network connections, geography. It may be depend on various other things. So what will happen in this scenario? The server with have capacity of only receiving 2 traffics or 2 requests per time, it will get 3, which regards to non-functioning of this server. Okay, and here this server which has the capacity of receiving or processing 4 requests at once will be underutilized, so it leads to some form of inefficiencies. And referring back to analogy above, imagine the okay. whose job is to direct customer into lines. Imagine this employee simply goes in order, assigning the first customer line 1, second to line 2 without looking back to quickly hire. If all 8 cashiers perform efficiently, the system will work fine. And but if one or more is lagging behind, some lines may become far longer than other. And suppose there are 7 requests, so we have started from there, 1 2 3 4 5 6. Seventh request will automatically fall on this side, which leads to more inefficiency. So this server will go to, or this server will burn in hell. So first is round robin DNS and client side random load balancing are the two common form of static load balancing. Okay, next is dynamic load balancing. The dynamic load balancing algorithms takes the account of availability, workload, health of the server in account, which means they can shift traffic from overburdened or poorly performing servers to underutilized servers, keeping the distribution even and efficient. However, dynamic load balancing is more difficult to configure. A number of different factors play into server's availability, the health, and overall capacity of each server, the size of the task being distributed, and so on. Okay. And if suppose we have a grocery store in which we have a specific employee that sorts the customer into checkout lines, uses more dynamic approach. The customer watches the line carefully, sees which lines move fast, observe how many groceries each customer is purchasing, and etc etc. You can read that, and I am very sure that you got the idea what I'm trying to convey. Next is, where is load balancing being used? So as discussed above, load balancing is often used with web applications. Software based and cloud based load balancers help distribute internet traffic evenly between server and host of the application. Now we are studying about a process known as GSLB, which stands for Global Server Load Balancing. And load balancing is commonly used within large localized network like those within a data center or a large office complex. Traditionally, this has required the use of hardware appliances such as ADC, which stands for Application Delivery Controller, or a dedicated load balancing device. Okay, so I think we need to copy this and save in our favorite note taking app, which is VS Code. Look what it has become from doing web development to mere taking notes. So we starting from GSLB. I think we have already written GSLB. So this time we are just writing ADC, which stands for Application Delivery Controller. Now these guys are begging for the updates. Okay, never mind. So next is server monitoring. The dynamic load balancers must be aware of the server health, their current status, how they are performing, etc. The dynamic load balancers monitor servers by performing the regular server health checks. If a server or group of servers is performing slowly, the load balancer distributes less traffic to it. If a server or group fails completely, the load balancer reroute the traffic to another group of server known as failover. I think we are in the current office. Actually, we are not performing some form of load balancing, but we do perform the process of failover, and we are doing it as using a protocol known as VRRP, which stands for what it stands for VRRP, which stands for Virtual Router Redundancy Protocol. I said it first, even before the loading. So virtual router redundancy protocol does what is it simply shares the traffic. Once again, let me again raise my pen. So suppose we have two router performing the same function, or we can say if we have two firewalls, because we are using VRRP in our current job to redundant the first router. Suppose we have to make some changes to the first router. If we turn off the first router, the load, the incoming or the egress load or the ingress load, I guess this is the ingress load, the incoming load, and this is the egress traffic, egress load. So it automatically be redirected from here to this side because this server just get cache. And I have to ask another question from my senior whether we are using preemption or not. Preemption is the method by which a disabled server once get active again, it will automatically gain the active position, and the secondary one automatically gets the standby position. So I have to ask that with senior. Maybe I can confirm in further videos. So this is the case. So we are providing the redundancy using VRRP. And this is a form of redundancy, and the process of switching traffic from this side, or this, if we can name this side, the side A from side B, is called as failover process. Failover process. Now, we have some different aspects of load balancing. First is load balancing algorithms. Then we have talk about global server load balancing. Then we have some router load balancing. What was that? It is called. Uh, actually didn't. HSRP, Hot Standby Router Protocol, and there was another one, HSRP, VRRP, HSRP, VRRP, and GLPB, Global Load Balancing Protocol. Okay, so it no GSLB, GLPB, Global Load Balancing Protocol. One second, GLPB, GLPB meaning GLPB, Gateway Load Balancing Protocol. Okay. So we have something for servers, and we have something for routers, because router or gateway is quite synonymous. Okay. We also have DNS load balancing, we have server failover, and we have load balancing across multiple clouds or multiple cloud providers. Then we have Cloudflare load balancing, and now we also have some Cloudflare load balancer, which might be a cloud application that we can use. So we will also see that. Now time to switch to next article in the load balancing context. We have server failover. We do discuss what the failover actually means. So let's read about it. So server failover is the practice of having a backup server prepared to automatically take over if the primary server goes offline. The server failover works like a backup generator. So when the power goes out in a building or home, a backup generator temporarily restores electricity. Similarly, in the server failover, a secondary server takes over the primary server, and goal of the server failover is to improve a network or website tolerance. Okay. The primary server job is to store content and data, while the other with and share it with other computers. There are different types of server, and perhaps the most well known because they keep the website and application operational. When the web server fails, they cannot process requests, which means they cannot serve data to client. And without a server failover, fail server can cause a loading error or outage. And server failovers reason. This is the first question that I asked, why a router get failed. Not in context of server, but why a failure in our data center or in our data team happens. Because I2K2, where I am working right now, is primarily a data center company which provides the data storing services, and partially it also provides some kind of cloud services. For example, you can purchase or rent compute resources also by us. So, what are the reasons that a gateway often fails? Power outage is the least probable because we do have some backups. Some natural disasters is probably one, but I am sorry that I put a cross here. But I actually means that it is the least occurring cause, because we do know that the power outage may become a reason. So we do have a preparations regarding that. We have multiple generators, battery backups, etc. Unexpected traffic surges, mostly you can say the DDoS attacks. And here it is written. Unexpected traffic surges may be from the flash sales, maybe the website that is being purchased having a flash sale. So multiple users started to log in on that website, and the server becomes stalled. Now we have hardware complications like cable problems and overheating. Yes, this was the answer that I was looking for. Cable problems. Suppose we are extensively using RJ45 cables. So we do have 8 pairs for redundancy, of course, because we know that the 4 cables, two of them are receiving, two for are sending, and I am very sure that the 4 extra remaining pairs must be used for redundancy. But even after that redundancy, failures may occur. Maybe the port itself got some kind of failure, or the wire has been cut down by some construction. Anything can happen. We do have operating system issues, because after running our device for multiple hours in continuous position, the device may be stuck in some jam state or hang state. So we do have to restart the device or reload the files. So no one can fully predict what or how a server might fail. And our IT leaders know that this server failure is inevitable. It cannot be avoided. So failover is a backup plan that helps to prevent a complete outage. The failover often goes hand in hand with a process called load balancing. Sometimes even if you do not load balance, you must have to be prepared for failover. Okay? Now let's talk about a few things about the server redundancy also. The server redundancy is the measure of how a backup server are in place to support a primary server. What is the difference between failover and switchover? Yes, this is the thing that need to be reminded. The term failover and switchover are sometimes confused. In failover, the shift to a redundant server happens automatically, while switchover is a similar process, but switch or the shift to the secondary server happens manually, creating a short period of downtime. Okay, so that's the difference. And how does the server failover work? We do have some protocols, because everything in networking is a protocol. So we do have a protocol for this task also. And for server failover to work, this server must be connected so they can sense issues and take over when necessary. So we do have states regarding the failover. Okay. One second. Before switching to next article, let me read this. Cloudflare load balancing periodically sends HTTPS requests to the server pools to monitor their status. If the check reveals that a server is unhealthy or offline, the Cloudflare will reroute the traffic to an available server. Okay, and now we have some states. We have active standby states, active states. So first let me exemplify it using two servers, S1 and S2. These are in active state, active. And in this scenario, this is the first scenario. Actually, I have to write it as second scenario because this is the one, but never mind. And second scenario, we have active passive state or standby state. Active and standby. Standby. Okay. So in active configuration, both server must remain active, and active configuration is typically associated with load balancing because the server are configured in the same way and shares the workload. When this server fails in active configuration, the traffic routes to the operational server or the servers. Okay, and in active standby, the primary server or the most secondary server in a two server setup, the secondary server monitors the primary one but remains inactive. Okay. So this is the current scenario that our office is following, the active standby scenario. So even just right in the sense the active fails, the automatically load balancing will started by the standby server. So it is not actively participating in the routing of traffic, but it is actively waiting in order to get the load or in order to share the load from the active. Once it's after its failover, and this is the load balancing scenario in which the load, ingress load or egress load are equally shared by both routers or both servers or both devices. Next, why server failover is necessary? because server availability can impact industries differently. uh, you don't even need to read this article. Uh, you just have to imagine that what will happen if the YouTube goes down for half an hour. What will happen? How you can watch my videos? This is much more to ask. But what will happen? You are not able to communicate. You are not able to share your thoughts. Your time will not pass. And much more important, like medical emergencies or emergency services are not able to, because some services are non-negotiable. Availability is non-negotiable for industries that meet urgent needs. Apart from availability, failover is also important concept for the most disaster recovery plans. The disaster recovery plans encompasses scenarios like field backups, a network going down, or even power outage. The disaster recovery companies maintain the continuity to avoid lost revenue associated with downtime. Now we have a failover cluster. A failover cluster refers to group of two or more servers that work together to make the failover possible. A failover cluster creates the server redundancy that enables high availability and continuous availability. So there's a difference between HA and CA. And I'm very sure that I have read in some previous articles about the high availability and continuous availability. So most of these things will be revising it. Never mind. So the system that aims as little downtime as possible, for example, 99.999% uptime, are considered high availability. So if a high availability system experience downtime, it only lasts a few seconds or minutes at a time. High regulated industries like government service may need high availability standards for compliance purpose. While continuous availability, on the other hand, are created to avoid any downtime at all. So no downtime means the user can stay connected to a site or application at all times. So I think, or as per my understanding, on the current level, the continuous availability means the requirement is active plus active, active plus active. So even in the scenario that first one goes down or dead, this load is still carried over by the second server. While in the case of high availability, there is enough time. For example, in the 99.999%, so there is still 0.0001% left in order to make a switch between active and standby. So even if the active goes down, the load will take few milliseconds or a few times, depending on the configuration, to switch to standby. Then standby will become automatically the active. And then engineers like us, network engineers, will try to activate the router again. And if the router has a function called preemption, then as soon as the first router becomes active, the load will automatically shift to the active router. I am actually repeating the word preemption. Keep this word in mind because we are going to see and read more about thing in coming time. Now, we have some fast failovers. As failover configurations can operate slightly differently, the speed at which the failover happens can vary. Some load balancers offer fast failover, which means the system monitors server health and quickly failover when needed. Fast failover is essential to have HA or CA, which is high availability and continuous availability. Cloudflare load balancing achieves the fast failover by actively monitoring servers and instantly rerouting traffic when an issue is detected. Cloudflare is something great. Next, now we are discussing about DNS based load balancing. It's a very short article as far I can see. After that, I will require just a water break. Okay. So starting from our DNS based load balancing. So we already know that load balancing is a practice of distributing traffic across one or more servers to improve its performance and availability. Organization uses multiple forms of it. We have seen the active standby configuration. We do have all different kind of configuration depending on the protocol. Now, DNS is often referred as the internet's phone book because it translates domains like google.com and times into IP address. And I do have to revise the DNS from my own video or from the Cloudflare article. So you guys, I also remind you that even after making you to understand this kind of article and reading myself, I'm still not able to gather the DNS all in my mind, so I do have to revise it, revise it. So I am also requesting you guys, please read the DNS again, because DNS is not just the phone book, it much more than that. And an IP address is a long numerical label used to identify websites or any device connected to the internet. By translating domain name into IP addresses, process called DNS resolution, the DNS saves people from memorizing long sequence of number to access website and application. So in DNS resolution, the internet users browsers contact our DNS server to request destination website to correct IP address. Okay. The act of requesting an IP address from a domain is called DNS query. Okay. And the DNS based load balancing is specific type of load balancing that uses DNS to distribute traffic across several servers. And this is done by providing different IP addresses in response to DNS query. The load balancers can use various method of rules for choosing which IP address to share in response of a DNS query. And one of the most common is called round robin DNS, which is a static form that we have just discussed. So what is round robin DNS? So round robin DNS has the same goal as the other kind of DNS based load balancing, to improve website performance and reliability by distributing traffic. However, opposed to using a specialized software based or hardware based load balancer, round robin performed using type DNS called authoritative name server. Okay. The authoritative name server hold the DNS record called A record for IPv4 addresses, 4 A records for IPv6 addresses, which contain domain's name and its matching IP address. So when a client submits a DNS query, query's goal is to find A or quad A records. A domain name will have single A record tied to the single IP address in the basic setup, meaning a DNS query will always return the same IP address. Sorry. So, however, in the round robin DNS, the domain have multiple A records, each tied to a different IP address. A DNS query come in and IP address rotate in round robin fashion, reading the request. Okay. Domain have multiple A records, each tied to a different IP addresses. Okay. Authoritative name servers hold DNS records called A record or 4A records, which contain the domain's name and its matching IP. Okay, suppose we have a DNS and A record. Okay, but how does A records look like? Suppose it contains some IP addresses mapping. Okay, so we have multiple mappings to a single name. Suppose this is an example.com. Okay, example.com. It's a website. It has multiple mappings, one mapping, two mapping, or three mapping. So after this mapping has been visited, it automatically shuffles down to the down of the row. Then after that, this will happen and it also be shuffled, and this after this also be shuffled. So what will happen that it goes in round, hence the name is round robin. Okay, why not? Let's see the example of a kya what A records, how an A records look like. Okay, A record, how does it look like? So this is A record, this is the website name, and it is the mapping of its IP address, and and we also have the time to live as well, which stands for TTL. So how much time this records will be stay in place. As for I'm very sure that this TTL signifies the caching of this thing. Okay, you can refer to my DNS video if you are very much interested in the uh, understanding of the A record. I have explained much more than this over there, and even I am also trying to watch that video while sleeping. Actually, my videos are perfect for sleeping. You just have to speed it up so you guys get the things in brain, and as your brain got filled with my crappy stuff, you automatically fall into sleep. So that's also an advantage with my video. Now, how does round robin DNS actually works? So if there are 5 IP addresses in round robin, a DNS query will only return IP address for the first, for every 6 requests, because the each IP address correspond to a different. I think I purposefully explained what I am trying to convey via this diagram. Okay. Next, what other types of DNS based load balancing are also there? So while the load balancing approach is popular, it is not the only method for routing traffic. Most load balancers also allow domain owners to choose from several routing rules. Round robin is one of them. So one example of a DNS based load balancing configuration is weighted algorithm, where different servers are assigned relative weights, which is based on the capacity of handling traffic, and traffic is assigned proportionally depending on the weight. And the weight is the same thing that is assigned on a BGP path, because I am also studying a lot about BGP in behind the scenes. So we will cover that in our upcoming videos, because I do actually take a oath to cover the articles, cover the all articles regarding the education on the regarding the learning platform on the Cloudflare. So that thing will also come here. Don't worry. So many of the DNS based load balancing approach are dynamic, meaning the load balancers considered server health, server response time when assigning requests. Dynamic algorithms can take many forms. Least connection is one type of dynamic. Yes. Here is the first tip. I'm not able to write. Okay, so I've selected eraser. That's why. This is least connection. The least connection is one type of dynamic load balancing algorithm. In least connection configuration, server monitoring is determined which server currently has the fewest open connection. Okay, and then assigns incoming traffic to server by providing its IP address in response to DNS query. Since it is dynamic, it automatically connects to or correlates to server to check its health, whether how many connections are opened on this server. So if it's report that it has 5 connections open and the other reports that it has 15 connections open, in the upcoming load, the future load will be assigned on this server. Okay. Now, geolocation is another widely used dynamic algorithm, and in this configuration, the load balancer assigns requests from region to a defined server on the server set. For example, all requests coming from France goes to server F, and here yes, F stands for France, and all requests come from Spain goes to server S, and yes, S stands for Spain. So mindful of me. Next, another algorithm is proximity based algorithm, which accomplishes something similar kind of geolocation algorithm. But in this configuration, the load balancer dynamically assign traffic to the server closest to user. Okay. And dynamic algorithm follows slightly different rules, but ultimately do the same thing: monitor server health and optimize how traffic is assigned. And when how Cloudflare's DNS based load balancing work, we can see that it actively monitors the server health, because we have just seen with the diagram. Based on the result and health checks, the Cloudflare steers the traffic toward healthy origin server and away from the unhealthy server. These are the words, that's why I love Cloudflare articles. Cloudflare steers traffic towards healthy origin server and away from the unhealthy servers. The Cloudflare load balancing also offer customer reverse proxy. What is reverse proxy? Let me take a small sneak peek regarding the video. I am already covered in previous video. I am tired of saying this, but let me cover it. Suppose this is client. Let me number it: client 1, client 2, client 3, and client 4. This is the global internet. I stands for internet, and this is the server 1, server 2, server 3, server 4. So in typical fashion, when we do not use any form of proxy or reverse proxy, the internet traffic will start from client 1, global internet, and the internet will redirect the request to their server. Then server will respond and the request will be sent to client. Ultimately, after trace routing it, client can know the name of the server, and server can see which client is being connected. So this is the very what to say in English, common life. Now we are introducing some guest. Now we have a computer here. We call it P1. So the computer is right in the between of client and the internet. So now my future diagram is drawing from the blue pen. So keep that in mind. Suppose client 2 is requesting for a website. The request first gets to the P1. Then after P1, the request is forwarded on the wild internet. And then from wild internet, the request is going for S2, the server second. Then server S2 will respond, the P1 will receive that response, and the response will be traversed to client 2. And in this scenario, the client 2 might be able to see S2, depends on the configuration, but S2 will only able to see the P1 as their client. And this is the proxy. When the proxy server or an alternate machine sits between client and the internet. Now in next scenario, we do have a new machine, stands for P3, which now stands between server, internet and client. So what will happen in this scenario? Now client 3, let's consider that in this scenario, we don't have a P1. Okay. I should actually name it P2 instead of P3. Let me correct it. Yes. Such an idiot. Yes. So, what will happen in this scenario? Suppose client 3 or client 4 requesting something on the wild internet. The request goes as follows. Now the request is received by the P2, and now after that P2 will forward this request to S3, and now S3 will respond it to P2. P2 will traverse the response to internet, and from internet the response will be forwarded to C4. Now this scenario has been what to say transformed. The table has been turned. Now S3 can see which client is requesting this. In this scenario, the C4 depends on the configuration of the proxy server, but C4 can only see the P2 as the whom the request has been made towards. They are not able to convey that the request has been served by S3, and this is called the reverse proxy, and this is called the normal proxy. So in simple words, it is basically the positioning of the external server. In this case, it may be between client or internet, or in other case, it may be between internet and this server. And I am very sure that you get the idea what I'm trying to convey. Now time for a little bit break so I can have a mouthful of water. Wait. Thank you for waiting, and now the time has come to read the second article in the following series. We were studying about DNS load balancing. Let's see what is next. We have load balancing algorithms. What is load balancing algorithm? You say once again. Let it load, and we have just witnessed. Once again, sorry. It was not on the camera, but we have just witnessed. Let me scroll it once again. We have just witnessed the content jumping, or what it say in the terms of web development, or as a academically what we say content shifting. So we have just seen the content shifting in the Cloudflare article. Maybe it's not the website problem, it may be problem in my browser current configuration, whatever the case, but I've just seen. Now continuing, what is the load balancing algorithm? So load balancing algorithm is a software or hardware device that keeps any one server from becoming overloaded. Okay. The two primary approaches, the dynamic and the static. We have seen this. The dynamic load balancing algorithms have least connection, weighted least connection, weighted response time, resource based. Let's see and read each one by one. So let me reduce the distraction. Okay. So least connection checks which servers have the fewest connection open at the time and sends traffic to those servers. This assumes that all connection requires roughly equal wherever Once again. Least connection checks which server have the fewest connection open at time and sends traffic to those server. This assumes all server require roughly equal processing power. Okay. So this algorithm is beneficial when every other server deployed is of equal category or equal kind. Now we have weighted least connection, which stands for gives administrator the ability to assign a different weights to each server, assuming that some server can handle more or less connection than others. Uh, Going back to previous example, we can say that if a server 1 S1, which can handle traffic of 3 requests, and then we have server 2, why I'm keep writing server 2 as server 3, which can handles as a 6. So I don't know whether the how weight are assigned. So if we assign the weight, this is just exemplary form. It may be relevant or with the actual configuration. So we can assign a weight of 1 here. Okay. And for this, we can assign a weight of 2, which stands for every one request, this server can handle 2 requests. So this is how the distribution pattern will happen. Okay. Now we do have some different things, and now we have some response time. Suppose this is a new generation server which can respond in a few milliseconds, and this takes much longer. So in that scenario, the load is assigned in a different way. The higher response time will be assigned a higher weight. I am very sure that this might be the case, assigning a higher weight to the highest performance server. Next is resource based, which distributes the load balanced or load based on the resource each server has available at the time. We have a specialized software which is called agent running on each server, measures the server's available CPU and memory, and the load balancer is queries the agent before distributing traffic to that server. Now we have round robin, weighted round robin, and IP hashing. These are static load balancing algorithms which is work by same way, sharing the load in one to one sequence. If we assign weight, then it will become the weighted round robin. Sometimes in most of the context, both dynamic and static seems to work in this kind of same thing, or seems to work like or alike same kind of working. But there is a difference that it keeps an eye on the server itself, checking its health, performance, resource, while static does nothing and just has a pre-programmed, pre-assigned program, and it goes by that. IP has is a new thing which combines the incoming source and destination IP addresses and uses a mathematical function to convert it into hash, and based on the hash the connection is assigned to a specific server. Okay. Now, how does Cloudflare load balancing work? It uses health check to steer traffic towards the healthy server. We have seen that, and this approach is known as global server load balancing, which is itself an article. So we do have to go by two more articles. Multi-cloud hybrid load balancing. Let's see. So what is load balancing? We have seen what is load balancing. What is different between hybrid and multi-cloud load balancing from traditional load balancing? Yes, this is a new thing. Let's see. Many applications today rely on multi-cloud providers or hybrid cloud, a mix of public and private cloud or data center infrastructure. In such circumstances, load balancing server or across server is often not enough to boost performance. Distribution or distributing traffic between cloud and data center is as important as distributing traffic among individual server. One cloud running far more load than other can drive up cost and reduce performance. By distributing load effectively, this can be avoided. Okay. So many cloud vendors have a function, built-in function, or we can say presets. Okay, which within one cloud service provider infrastructure, not across multiple service. Okay, meanwhile traditional load balancers are hardware based, which is inefficient for distributing traffic to far flung cloud servers. Okay, in that scenario, because of the distributed nature of cloud computing, multi cloud and hybrid cloud load balancing perform agnostic, software based, and global. So first is performant agnostic. Let me see the what this word means. Agnostic. Copy it. Agnostic. What does it pronunciation mean?
Agnostic.
Agnostic, which believes that it is impossible to know whether there is a god or not. One who is skeptical about the existence. So the context actually directs towards skeptical. Okay. So platform skeptical load balancing. A multi-cloud load balancer that has able to distribute traffic regardless of the underlying infrastructure and cloud services. Okay. So which platform agnostic, which means that does not care about the platform it is running on, or we can say cross platform. Look what you have become. You are not trying to be one. Cross platform. Next is software based. A hardware based load balancer cannot efficiently direct traffic across cloud because traffic would bottleneck within the data center where the load balancer runs. Conversely, a load balancer that runs in software instead of hardware can run anywhere, and multi cloud load balancers are also software based. Now there is global. Public clouds are distributed geographically to reach users in any region or serve traffic to any cloud or origin server located anywhere. Multi cloud load balancers need to be able to direct traffic globally. And because of these attributes, multi cloud load balancers and hybrid cloud load balancers are often offered as a cloud service. These are most effective when they run on distributed network. Ooh, few of these things really tall over my heads, but don't mind. These things are not very complicated because load balancing is a fun thing to learn. And now let's see about LBAAS, which stands for cloud based load balancing. Cloud based load balancing. Where is C? I can see L for cloud. Okay. So, cloud load balancing is a software based load balancing service that distributes the traffic between multiple cloud servers. And I'm very sure that Amazon has a service in AWS regarding it. So Amazon load balancer, let's see what it is called. ELB, elastic load balancing. And I'm very sure that it must have a fun logo regarding it. Yes, elastic load balancing. Do have benefits, how it works, customers. Wow, what's a beautiful website it got. I just wanted to see its logo. It open, let it load, let it load. Yes, this is the logo, load balancer. Yes. So next thing is cloud load balancing is a software law. We have read about it. Like hardware load balancers, cloud load balancers are designed to manage massive workload so that no other server can become overwhelmed by the request, which can increase latency and cause downtime. Many cloud providers allows customer to rent load balancing service on as needed basis rather than configuring and maintaining dedicated on-premises appliances to route their traffic themselves. This process is often referred to as load balancing as a service. And actually, guys, I want to share you some excitement with regarding that how we can manage the offline devices or segregated devices using only software. Suppose in my environment on this specific PC that I'm on recording on, actually I can run a virtual box with a voice OS on it. I've already told you that my organization uses this OS extensively, voice OS, which is a firewall, a router in itself. And yes, this is the voice OS box. By running voice OS box and configuring the external devices like this by their default gateway of the interface on this OS, I can assign multiple interfaces and even assign IP addresses to it as an ingress interface. The traffic of this device can be handled or can be firewalled by using this voice OS, which is such an achievement in the networking that I am actually fan of. And I'm very excited to go office tomorrow just order to do that. And I'm going to learn a lot about voice OS in tomorrow's video or session, not video session, but within office session. So what I will do, I will be configuring firewall rules, understanding the syntax, how the voice OS works, etc. etc. It tomorrow will be going to a fun day. So coming back to the topic, why is load balancing necessary for cloud computing? For cloud hosted application, the load balancing is an essential service. Just an individual server running in a data center can become overwhelmed and fail, causing significant latency and potential outage for end users. So can server running in the cloud. So if there is an hardware, because ultimately even in cloud there is an hardware present somewhere, it can fail. So hardware load balancing appliances not only are inefficient as managing traffic in the cloud, but often prohibited from running vendor managed cloud environment as well. Software based load balancers, meanwhile, can run in any environment and location, making them more suitable for cloud hosted application and infrastructure. Next is regional cloud balancing, regional cloud load balancing versus global server load balance. One second. My stylus is going funny. Wait a second. Yes, now it's back. So, cloud-based load balancers encompasses both regional load balancers and global load balancers. As the name suggests, the regional load balancers are designed to reduce the strain on computing services within a specific region or localized network. While on the other hand, global load balancers can achieve workload across several servers or across servers in the multiple locations worldwide, vastly cutting down the latency and to the end user. Okay, so regional targets the region and global targets the worldwide. Okay, so quite self-explanatory, and advantages of using cloud-based load balancers, which is reduced cost, scalability, and global availability. And yes, Cloudflare do provide these kind of services. And this is how videos for the day 22, 22 of what? 22 of December ends. Thank you very much. Thank you for joining. And let me show you guys my pretty face. Thank you. Thank you very much. Thank you for joining.